Hello student, now in this video we will see the chapter ratio and proportion. Full chapter. I will explain all examples in a very simple language. Now let us start. Ratio and proportion. First, ratio. A ratio is a comparison of two or more quantities of the same kind and with the same units. Okay. Ratio of two numbers A and B is the quotient, that is A upon B. The ratio of A to B is written as A as to B, and that's equals to A upon B, where A is called antecedent and B is called consequent. Okay. A and B are called the terms in the ratio. Okay. Next, fact about a ratio. Now, first, ratio of two similar quantities is found. For example, we do not find the ratio between height of a student and his weight. Second, ratio should be expressed in its lowest term. Okay. For example, 40 upon 12. Then we divide here 40 upon 4 and 12 upon 4, and then you will get here 10 upon 3, that is in the lowest. Okay. Now next, no units are written in a ratio. For example, if areas of two triangles are 64 centimeter square and 36 centimeter square, we write their ratio as 64 as to 36, and that's equals to 16 as to 9. Okay, again here we divide these two numbers by 4, and then you will get here 16 as to 9. Next, the order of the terms in a ratio is important. Means what? Find the ratio of first quantity to second or second quantity to the first, and hence the order of the terms in a ratio is important. Next, ratio is taken only between positive quantities. The quantity must be positive. Next, value of ratio remains the same when both the terms are multiplied or divided by the same number. Now see this here. That is, if we have a ratio A upon B, if we multiplied, then its value remains the same. If we divide by k, then its values remain same, where k is not equals to 0. Now here we see the one example. Example number 1. If x square plus y square upon x square minus y square is equals to 17 upon 8, find the value of x as to y. And second, x cube plus y cube upon x cube minus y cube. This question asking board examination. Okay. Now in this method, we have solved this in another way. But actually, we solve this type of example by using the componendo and dividendo. But this is also one of the method. See this here. Now the solution here. X square plus y square upon x square minus y square is equals to 17 upon 8. Okay, first cross multiplication. Then 8x square plus 8y square and is equals to 17x square minus 17y square. Now collect the terms y square and x square on the same side. Therefore here 8y square, shift this minus 17y square to the left hand side, and that's equals to 17x square. Now again shift this to the right hand side, it will become minus. Then next simplification, 8y square plus 17y square, then you will get here 25y square. Okay, 17x square minus 8x square, you will get here 9x square. Now we require here x as to y. Therefore, transfer this y square to the right hand side. Therefore, x square upon y square is equals to 25 upon 9. Now take square root on both sides. Therefore, x as to y. or x upon y is equals to 5 upon 3 or x has to y is equals to 5 has to 3, and this is the first one. Now we solve this type of examples by using the componendo and dividendo also. Okay, next, x cube plus y cube. We find out the value of x cube plus y cube upon x cube minus y cube. Now divide numerator and denominator by y cube. Then you will get here x cube upon y cube plus 1 upon x cube upon y cube minus 1. Now what is the value of x upon y? Is 5 by 3 bracket cube plus 1. 5 by 3 bracket cube minus 1. And then simplify. 5 cube, that is 125 upon 27. Okay, here 125 upon 27 plus 1. And next is a 125 upon 27 minus 1. Then simplify. 27 into 1, that is a 27. Therefore 125 plus 27 upon 27. This whole divided by 125 minus 27 upon 27. Okay, and next simplification. Okay, and after the simplification, you will get here x cube plus y cube upon x cube minus y cube is equals to, here 27 get cancel. Okay, both the denominator terms. Okay. Then you will get here 152 upon 98. Again divide these two terms by 2, and then you will get here 76 upon 49, and hence the value of x cube plus y cube upon x cube minus y cube is equals to 76 upon 49. Okay, this is one of the way. Okay, we also solve by using the another way also. X upon y is equals to 5 by 3. Take cube on both sides. Then apply the componendo and dividendo in next type of examples. Okay. Now next part is a proportion. Okay. Proportion describes how two quantities are related to each other. When two ratios are equal, then four quantities are said to be in proportion. That is, if we have A upon B is equals to C upon D, then we say that A, B, C and D are in a proportion. Okay. Now we will see here. If A has to B is equals to C has to D, then AB and ABC and D are said to be proportional, and D is called the fourth proportional. A and D, the first and last terms, are called extremes, and B and C are means. If A upon B is equals to C upon D, then their cross multiplication AD is equals to BC. The product of extremes is equals to product of means. Okay. Now next, continued proportion. This is also very important. If A upon B is equals to B upon C is equals to C upon D is equals to D upon E. Okay. Then A, B, C, D, E and the next are said to be in continued proportion. If you observe here, this denominator B is continued in the next ratio. If you observe here, denominator C, it is continued here in the next ratio. Okay, and in this way we call this as the continued proportion. Okay, if A upon B is equals to B upon C, then A, B, C are in continued proportion, and here B square is equals to AC. That is A into C is equals to B into B. B into B is a B square is equals to AC. Now here note that if A has to B is equals to B has to C, then B is called mean proportion of A and C, and C is called the third proportion to or of A and B. Now properties of proportion, and this is very important. If A has to B is equals to C has to D, then A upon B is equals to C upon D. Now taking a reciprocal on both sides, we get here that is the invertendo, and it is called the invertendo. Reciprocal of this is a b upon a, and that's equals to reciprocal of this is a d upon c. Okay, therefore the if a has to b is equals to c has to d, then b has to a is equals to d has to c is called the invertendo. Now next, alternando. Now what is meant by the alternando? If we have the ratio that is a upon b is equals to c upon d, then a upon c is equals to b upon d is called the alternando. Means what? If we shift here c in this in place of c and c and to the place of the b, and then it is called the alternando. Okay. Or if a has to b is equals to c has to d, then a upon c is equals to b upon d. Now next componendo. If a has to b is equals to c has to d, and if we add 1 on both sides and then simplify, that is b into 1, then you will get here a plus b upon b, and that's equals to again d into 1 plus c, that is a c plus d upon d, and hence here a has to b is equals to c has to d, then a plus b upon b is equals to c plus d upon d, then this is called the componendo. Okay, next dividendo. If we have a upon b is equals to c upon d, then subtracting 1 from the both sides, okay, then simplify, that is b into minus 1 upon b, that is a minus b upon b is equals to d into minus 1, then you will get here c minus d upon d. This is called the dividendo. If a upon b is equals to c upon d, then a minus b upon b is equals to c minus d upon d. This is called the dividendo. Okay, and hence again I will repeat here. If a has to b is equals to c has to d, then a plus b upon b is equals to c plus d upon d. This is called the componendo. And next is a minus b upon b is equals to c minus d upon d. This is called the dividendo. Okay, and the next combination of these two, componendo and dividendo. First, if a upon b is equals to c upon d, then by componendo a plus b upon b is equals to c plus d upon d. This is the first one. What is next? By dividendo, a minus b upon b is equals to c minus d upon d. This is the second one. Now take the ratio of these two equalities. Means what? We divide this left hand side of this equality to the left hand side of this equality. Means what? A plus b upon b, this whole divided by a minus b upon b, and that's equals to c plus d upon d, and this whole divided by c minus d upon d. See this here? Okay, dividing 1 by 2, then a plus b upon a, this whole divided by a minus b upon a, and that's equals to c plus d upon d, this whole divided by c minus d upon d, and here both the denominator get here cancel, here also get cancel, then you will get here a plus b upon a minus b is equals to c plus d upon c minus d. Okay, next, therefore a plus b upon a minus b is equals to c plus d upon c minus d. And hence, now what is the component by dividendo? If a upon b is equals to c upon d, then a plus b upon a minus b is equals to c plus d upon c minus d. Okay. Now next. Now example number 2. If a, b, c, d are proportional, then prove that 5a plus 7b upon 5a minus 7b is equals to 5c plus 7d upon 5c minus 7d. We will solve these examples with the help of two methods. First method is K method. It is called the K method. Okay. Then what is here? A upon b is equals to c upon d, and that's equals to k. That is the value of this ratio is equals to k. Therefore, a is equals to A upon B is equals to K, and hence A is equals to, we will get here, BK. C upon D is equals to K. Therefore, C is equals to BK. Now substitute the values of A and C first in LHS, then RHS, then show that LHS is equals to RHS, and hence it is approved. Now see this here. Okay. Now LHS. 5A plus 7B upon 5A minus 7B. Substitute the value of A. What is the value of A? A is BK plus 7B. To the denominator, value of A is BK, 5 in bracket BK minus 7B. Okay. Now from the numerator and denominator, take B as common. Then in bracket you will get here 5K plus 7 upon, again here to the denominator, take B as a common. In bracket 5K minus 7. BB get cancelled, and then you will get here 5K plus 7 upon 5K minus 7. This is your LHS. Now, what about the RHS? RHS is 5C plus 70 upon 5C minus 70. Substitute the value of C here. C is a dk. 5 into dk plus 7d. Next is a 5 into dk minus 7d. Take d as a common. From the numerator and the denominator, dd get cancelled. Then you will get here 5k plus 7 upon 5k minus 7. That is, for the LHS, you have 5k plus 7 upon 5k minus 7, and for the RHS, 5k plus 7 upon 5k minus 7. Therefore, here from 1 and 2, LHS is equals to RHS. Consider it true. LHS is equals to RHS, and hence we have proved that 5a plus 7b upon 5a minus 7b is equals to 5c plus 7d upon 5c minus 7d. In this way, we have proved it. Now again, second method. Okay, this is also very interesting method. If you observe here, the coefficient of A is 5 here, coefficient of B is 7. Observe here, the coefficient of C is 5 and the coefficient of D is a 7. If we multiplied this ratio, that is A upon B is equals to C upon D, that is coefficient of A is 5, that is into 5, coefficient of B is 7 into 7, that is multiplied for these two equalities by 5 by 7. Okay, now see this here, multiply both sides by 5 by 7. Then apply the componendo and dividendo, then you will get the required result. 5a plus 7b upon 5a minus 7b is equals to 5c plus 7d upon 5c minus 7d. Okay, using componendo and dividendo. Now, next example. If a plus c is equals to 2b and 1 upon b plus 1 upon d is equals to 2 upon c, then prove that a has to b is equals to c has to d, or a upon b is equals to c upon d. Now the solution. We have given that 1 upon b plus 1 upon d is equals to 2 upon c. Then here by the cross multiplication, 1 into d, 1 into b. That's a d plus b upon bd is equals to 2 upon c. Okay. Next, after again the cross multiplication, that is a c into in bracket b plus d is equals to 2 into bd. Okay. And the next simplification, substitute the value of 2b here. What is the value of 2b? 2b is a plus c. That's equals to, we substitute the value of 2b, that in bracket a plus c bracket complete into d. Next simplification, that is a into d, that is ad, c into d, cd. Cancel cd, cd from the both sides. Okay, we cancel cd from the both sides. Then you will get here bc is equals to ad. Okay, then shift this d to the left hand side and b to the right hand side. Then you will get here c upon d is equals to a upon b, and hence a upon b is equals to c upon d. Okay, and in this way we have proved it. Now next example, if 3a plus 4b upon 3c plus 4d is equals to 3a minus 4b upon 3c minus 4d. Then prove that a upon b is equals to c upon d. Okay. If we observe here, that is a 3a plus 4b and here 3a minus 4b. And what about here? 3c plus 4d. This 3c plus 4d must be here and 3a minus 4b to the denominator here. Therefore, here we will apply the alternando. By applying the alternando, you will get here 3a plus 4b upon 3a minus 4b is equals to 3c plus 4d upon 3c minus 4d. Okay, then apply the componendo and dividendo. You will get the required result. Okay, therefore by applying the componendo and dividendo, 3a plus 4b plus 3a minus 4b upon 3a plus 4b minus in bracket 3a minus 4b is equals to 3c plus 4d plus 3c minus 4d upon 3c plus 4d minus in bracket 3c minus 4d. If we simplify this bracket here, plus 4b minus 4b get cancelled. If we open the bracket, then here 3a minus 3a that will get cancelled, and this minus and minus that will become plus. Okay, therefore you will get here 3a plus 3a, you will get here 6a upon 4b plus 4b, and that's the 8b. Again, if we open the bracket here, that is a 4d and 4d get cancelled, you will get here 6c. And what about here? If you open the bracket, here minus 3c plus 3c get cancelled, minus minus will become plus. Okay, then you will get here to the denominator 8d. Now next, cancelling from the both sides 6 upon 8. 6 upon 8. Then you will get here a upon b is equals to c upon d. Okay, and hence a upon b is equals to c upon d. Now next problem, if 7m plus 2n upon 7m minus 2n is equals to 5 by 3, use properties of proportion to find the value of m as to n. Now here apply the componendo and dividendo. By applying the componendo and dividendo, 7m plus 2n plus 7m minus 2n, this whole divided by 7m plus 2n minus in bracket 7m minus 2n, and that's equals to 5 plus 3 upon 5 minus 3. Now here the plus 2n minus 2n get cancelled. If you open the bracket, you will get here minus 7m plus 7m get cancelled. Minus minus will become plus 7m plus 7m. Then you will get here 14m, and this divided by 4n, and that is equals to 8 upon 2 is equals to 4 upon 1. Okay, now next we want to find out m as to n, and that is equals to 4 upon 1 into, if we take shift this 4 to this right hand side, then it will become multiplied this ratio, and 14 the division. Okay, and hence here you will get here 16 upon 14, and that is equals to 8 upon 7, and hence here m as to n is equals to 8 as to 7. Okay, and this is the. Now next, to find the value of m square plus n square upon m square minus n square, we know that m upon n is equals to 8 upon 7. Squaring on both sides, then you will get here m square upon n square is equals to 8 square. Okay, and here is a 8 square upon 7 square. You will get here 64 upon 49. Now by applying the componendo and dividendo, then you will get here m square plus n square upon m square minus n square, and that's equals to 64 plus 49 upon 64 minus 49. Okay, and here 64 plus 49 is equals to 113, and their subtraction 64 minus 49, that's equals to 15, and hence the value of the ratio, that is m square plus n square upon m square minus n square, is equals to 113 upon 15. Okay, now next, the following numbers, that is a k plus 3, k plus 2, 3k minus 7 and 2k minus 3 are in proportion. Find k. As these numbers are in proportion, then you will get here k plus 3, that is first number divided by second number, which is the k plus 2. Next is a 3k minus 7 upon 2k minus 3, and next the cross multiplication, that is a k plus 3 into, next is a 2k minus 3, and that's equals to 3k minus 7 into, in bracket, k plus 2. Okay, next simplification, k into 2k, then you will get here 2k square, k into minus 3, that is a minus 3k, 3 into 2k, then you will get here 6k, plus 3 into minus 3, minus 9. Next is a 3k into k, that is a 3k square, 3k into 2, then you will get here 6k, minus 7 into k, minus 7k, minus 7 into plus 2, minus 14. Next here is a 2k square, okay, minus 3k plus 6k, then you will get here 3k minus 9, and that's to the right hand side. Here is a 3k square, 6k minus 7k, you will get here minus k minus 14. Now shift this to the right hand side, you will get here 0, 3k square minus 2k square, minus k and minus 3k, minus 14 plus 9. Okay, and after subtraction, you will get here k square minus 4k minus 5, and that's equals to 0. Now this is quadratic equation, k square minus 4k minus 5 is equals to 0. Now the product of these two is minus 1, k into, that is coefficient of k square is 1, and minus 5, minus 5. Then the factors of these are the k minus 5 in first bracket, and second bracket is a k plus 1. And if we simplify, then you will get here k is equals to 5 or k is equals to minus 1, and this is solution. Okay. Now next problem, if a raised to 4 plus 9 upon 6a square is equals to 5 by 3, using properties of proportion, solve for a. Okay, now here we will apply here the componendo and dividendo. Therefore, a raised to 4 plus 9 plus 6a square upon a raised to 4 plus 9 minus 6a square is equals to 5 plus 3 upon 5 minus 3. Then if we observe this here, a raised to 4 plus 9 means what? A square plus 3 whole square. Okay, therefore you will get here a square plus 3 whole square. And what about the denominator? Denominator, you will get here a square minus 9 whole square is equals to 5 plus 3 is 8, 5 minus 3 is a 2. We divide, then simplify this, then you will get here 4 upon 1. Now next, take the square root on both sides. Then you will get here a square plus 3 upon a square minus 3 is equals to plus or minus 2. Okay, and the next, if we take a square plus 3 upon a square minus 3 is equals to 2. Then it implies that if we take the cross multiplication here, a square plus 3, 2 into a square minus 3 means what? 2a square. 2 into 3, that's equals to 6. Then shift this a square to the right hand side and the minus 6 to the left hand side. 6 plus 3, then you will get here 9. 2a square minus a square, you will get here a square. A square is equals to 9. Taking the square root on both sides, therefore you will get here a is equals to plus or minus 3. For the next, a square plus 3 upon a square minus 3 is equals to minus 2. Again, next the simplification, a square plus 3. Shift this a square minus 3 to the right hand side, then it will become multiplied to minus 2. Minus 2a square minus 2 minus 3. Minus 2 into minus 3, that will become plus. Okay. Next, shift this minus 2a square to the right hand side. Then minus 2a square plus a square. You will get here 3a square. Shift this 3 to the right hand side. 6 minus 3. You will get here 3. 3a square is equals to 3. Therefore, a square is equals to 3 upon 3. A square is equals to 1. Taking square root on both sides, then you will get here a is equals to plus or minus 1. Okay. And hence, the values of a are a is equals to plus or minus 3 or a is equals to plus or minus 1. Now next problem, given that a cube plus 3ab square upon b cube plus 3a square b is equals to 63 upon 62 using componendo and dividendo, find a as to b. Okay. Now here we have a cube plus 3ab square and to the denominator b cube plus 3a square b is equals to 63 upon 62. Now applying the componendo and dividendo, then you will get here a cube plus 3, I will take first this 3a square b plus 3, then this a b square plus b cube and this whole divided by a cube plus 3a b square minus in bracket b cube plus 3a square b is equals to 63 plus 62 upon 63 minus 62 and that's equals to 125 upon 1. But what is this? A cube plus 3a square b plus 3ab square plus b cube, and this is nothing but a plus b whole cube. And what about here? If we simplify this bracket, that is a minus b cube minus 3a square b, and this is nothing but the expansion of a minus b bracket cube, and that is equals to 125 upon 1. Take cube root on both sides, then you will get here a plus b upon a minus b, and that is equals to, now 125 is a 5 cube and this is 1 cube. If you take cube root on both sides, then you will get here 5 upon 1. Again apply the componendo and dividendo, then you will get here a plus b plus a minus b, this whole divided by a plus b minus in bracket a minus b, then a will become minus and minus that b will become here plus b, and that's equals to 5 plus 1 upon 5 minus 1. These two terms get cancelled, plus a minus a get cancelled. You will get here 2a upon 2b is equals to 6 upon 4. And next, This again 2 get cancelled. You will get here A upon B. If we simplify this, then you will get here 3 upon 2. And hence A has to B is equals to 3 has to 2. And this is the answer. Okay. Again, now next, using the properties of proportion, solve for x. Okay, given that x raised to 4 plus 1 upon 2x square is equals to 17 upon 8. Okay, now apply here componendo and dividendo. Then you will get here x raised to 4 plus 1 plus 2x square is divided by x raised to 4 plus 1 minus 2x square, and that's equals to 17 plus 8 upon 17 minus 8. If we simplify this, then you will get here 25 upon 17 minus 8, you will get here 9. Now what about this? This is the perfect square. Perfect square of x square plus 1 whole square, and denominator is a x square minus 1 whole square, and that's equals to 25 upon 9. Take square root on both sides, then you will get here x square plus 1 upon x square minus 1, and that's equals to plus or minus 5 upon 3. Now first we will take here x square. Okay, see this here, x square plus 1 upon x square minus 1 is equals to 5 upon 3. Again apply the componendo and dividendo. Then you will get here x square plus 1 plus x square minus 1 upon x square plus 1 and minus in bracket x square minus 1. This will have the minus sign. Minus 1 will become plus, and here to the right hand side 5 plus 3 upon 5 minus 3. If we simplify this, plus 1 minus 1 get cancelled. Then you will get here 2x square plus x square minus x square get cancelled. 1 plus 1 will get here 2, and here 8 upon 2. This 2 will again get cancelled. 8 upon 2, and that's equals to 4. Next, x square is equals to 4. Taking square root on both sides, then you will have x is equals to plus or minus 2, and this is the first answer. What about the next? Next, if we take, that is the square root as a minus 5 upon 3, that is here x square plus 1 upon x square minus 1, and that is equals to minus 5 upon 3. If we take the cross multiplication, then you will have this type of the simplification, that is 3 in bracket x square plus 1, and that is equals to minus 5 in bracket x square minus 1. Then you will have 3x square plus 3 minus 5x square plus 5. Next simplification, shift this minus 5 square to the right hand side. Then you will get here 3x square plus 5x square. Okay, next is a 5 minus 3. Then you will have here, this is 2. Now next, 3x square plus 5 square, you will have 8x square. Okay, therefore x square is equals to 2 upon 8. Then after simplification you will have 1 by 4. Now take square root on both sides, then you will have that x is equals to plus or minus 1 upon 2, and hence the value of x is plus or minus 2 or plus or minus 1 upon 2. Now next example, example number 10. If a cube plus 3ab square upon 3a square b plus b cube is equals to 172 upon 171, find a as to b. Again, here we will apply the componendo and dividendo, and after applying, you will get here a cube plus 3ab square plus 3a square b plus b cube upon a cube plus 3ab square minus in bracket 3a square b plus b square. Okay, here must be b cube. Okay, here is a b cube equals to 172 plus 171 upon 172 minus 171. And if we simplify this, then what you will get here? A plus b whole cube. We take minus sign. Then you will get here a minus b whole cube is equals to addition of these 343 upon 1. Taking the cube root on both sides, then you will get here a plus b upon a minus b is equals to 7. Again, here the cross multiplication and then next simplification. Shift this minus 7b to the left hand side and a to the right hand side. Then you will get here 8b is equals to 6a, and hence here a upon b is equals to 8 upon 6, and if we simplify this, then you will get here 4 upon 3, and hence the ratio a as to b is 4 as to 3. This is the answer. Now next, if 3a plus 2b as to 5a plus 3b is equals to 18 as to 29. Find a as to b. Now here, if we observe the problem, that is a coefficient of a and b is different. Okay, therefore here 3a plus 2b upon 5a plus 3b is equals to 18 upon 29. Coefficient of a to the numerator is different, and b is also different. To solve this type of problem, next here the cross multiplication. Okay, therefore we will take here 29 into in bracket 3a plus 2b is equals to 18 in bracket 5a plus 3b if the coefficients are different. Then what is the multiplication? Then you will get here 29 into 3, that is 87a plus 58b, and that is equals to 18 into 5a, then you will get here 90a plus 18 into 3b, that is a 54b. Okay, and next simplification, that is 58b minus 54a, and that is equals to 90a minus 87, and their subtraction is a 4. Here is a 54b, subtraction is a 4b, and that is equals to 3a, and hence that is a 4 upon 3 is equals to a upon b. Transfer this 3 to the left hand side and b to the right hand side. Then you will get here a upon b is equals to 4 upon 3, or a as to b is equals to 4 as to 3. Okay, and this is the answer. Now next problem, in root of 3x plus 1 plus in root of x plus 1 upon in root of 3x plus 1 minus in root of x plus 1 is equals to 4. Use properties of proportion and solve for x. Now here we will apply the componendo and dividendo. Okay, and to the numerator, in root of x plus 1 minus root of x plus 1 get cancelled, minus in root of 3x plus 1 and plus get cancelled. This minus and minus will become plus, and overall you will get here 2 in root of 3x plus 1 upon 2 in root of x plus 1, and that's equals to 4 plus 1 upon 4 minus 1. You will get here 5 by 3. 2 get cancelled. Okay, Then you will get here in root of 3x plus 1 upon in root of x plus 1 is equals to 5 by 3. Squaring on both sides, then you will get here 3x plus 1 upon x plus 1 is equals to 25 upon 9. Next, cross multiplication. 9 into in bracket 3x plus 1 is equals to 25 in bracket x plus 1. And next simplification, 27x plus 9 into 1 is 9. 25x and 20 plus 25. Now transfer this 25 to the left hand side, 9 to the right hand side. Then you will get here 2x is equals to 16, and hence x is equals to 16 upon 2, x is equals to 8. Okay, and this is the answer. Now next, using properties of a proportion, solve for x. Again here we'll apply the component row and dividend row. After applying the component row and dividend row, then you will have here a root of 5x plus in root of 2x minus 6 plus in root of 5x minus in root of 2x minus 6, and this whole divided by root of 5x plus in root of 2x minus 6 minus in root of 5x minus minus will become plus in root of 2x minus 6, and that is equals to 4 plus 1 upon 4 minus 1. Okay, and the next simplification, these two get cancelled from the numerator, and here these two get cancelled. We simplify this, then you will have that is a 2 root 5x upon, here is a 2 times in root of 2x minus 6, and that's equals to 5 upon 3. Again here this two get cancelled. Squaring on both sides, then you will get here 5x upon 2x minus 6 is equals to 25 upon 9. Next, cross multiplication, that is 5x here, 5x into 9 is equals to 25 in bracket 2x minus 6. Okay, then you will have 45x is equals to 50x minus 150. And next simplification, transfer this 150 to the left hand side, it will become plus 50x minus 45x, you will get here 5x, and hence x is equals to 150 upon 5, and that's equals to 30, and hence the answer is x is equals to 30. Okay, now next problem, using again the properties of proportion, solve for x. Again this is very easy question, you can solve this again by applying the component row and dividend row. Okay, here the 2x plus in root of 4x square, okay, in root of 4x square minus 1 plus 2x minus in root of 4x square minus 1, this whole divided by 2x plus in root of 4x square minus 1 minus 2x, this minus and minus that will become plus, here you will get here 4x square minus 1, and that's equals to 4 plus 1 upon 4 minus 1 is equals to 5 upon 3. Next simplification, this 2 get cancelled, plus 2x minus 2x get cancelled. If you add this, then you will get here 4x upon 2 in root of, what is here? 4x square minus 1, and that is equals to 5 upon 3. Again, next simplification. Okay, 2 ones are 1, 2 twos are 4. You will get here 2x upon in root of 4x square minus 1 is equals to 5 upon 3. Now squaring on both sides, then you will get here, if we take the squaring on both sides, square of 2x is 4x square. Okay. Now here root sign and the square get cancelled. Then you will get here 4x square minus 1. 5 square is a 25 and 3 square is a 9. Next cross multiplication. 4x square into 9x square. Then you will have 36x square. Next is 25 into 4x square. You will have 100x square. 25 into minus 1, that is a minus 25. Now transfer this 36 to the right hand side and 20 minus 25 to the left hand side. It will become plus. Okay, that is a 100x square minus 36x square. Okay, now next is here 25 upon subtraction is a 64x square. Therefore here 25 upon 64 is equals to x square. Taking square root on both sides, then you will have here, that is, it implies that x is equals to plus or minus 5 upon 8. But x is positive, and hence it implies that x is equals to 5 upon 8, and this is answer. Okay, because I have given that x is positive. Now here is also similar problem using component and dividend to find the value of x. In root of 3x plus 4 plus in root of 3x minus 5 upon in root of 3x plus 4 minus in root of 3x minus 5 is equals to 9. Apply the component and dividend to, then you will have here in root of 3x plus 4 plus in root of 3x minus 5 plus in root of 3x plus 4 minus in root of 3x minus 5, and this whole divided by in root of 3x plus 4 in root of 3x minus 5 minus in root of 3x plus 4 plus in root of 3x minus 5, and that is equals to 9 plus 1 upon 9 minus 1. Here these two terms get cancelled, and the next is these two terms get cancelled. If we add numerator, then you will have, that is a 2 in root of 3x plus 4 upon 2 in root of 3x minus 5, and that's equals to 10 upon 8, and if we simplify it, then you will have 5 upon 4. Again here 2 to get cancelled. Now squaring on both sides, then you will have here 3x plus 4 upon 3x minus 5 is equals to 5 square upon 4 square. Okay, therefore you will have here 3x plus 4 upon 3x minus 5 is equals to 25 upon 16, and next is a cross multiplication. Here is 3x plus 4 into 16 and that is equals to 25 in bracket 3x minus 5. 16 into 3x, you will have 48x. 4 into 16, 64. 75x minus 125. And the next simplification, transfer this 48 to the right hand side. 64 plus 125, and here is a 75x minus 48x. Okay, here the addition of this is, there is a 9, 5 plus 4 is 9, there is a 8 and 1, and that's equals to 75x minus 48x, that is a 27x, and hence here that is implies that x is equals to 189 upon 27, and that is equals to 7, and hence what is answer? X is equals to 7. This is answer. Okay, now next problem. Now here example number 16. If x cube plus 48x upon 12x square plus 64 is equals to y cube plus 75y upon 15y square plus 125. Calculate x as to y. Again by using the componendo and dividendo. Okay. Then here the after simplification, opening the bracket, you will get a x cube plus 12x square plus 48x plus 64 upon x cube minus 12x square plus 48x minus 64, and that's equals to y cube plus 15y square plus 75y plus 125 upon y cube minus 15y square plus 75y minus 125. And now here is the x plus 4 whole cube divided by x minus 4 whole cube. And what about the right hand side? Y plus 5 whole cube upon y minus 5 whole cube. Okay, now take the cube root on both sides. Again, next is take the again by applying the componendo and dividendo. X plus 4 plus x minus 4, x plus 4 minus x plus 4, and to the right hand side y plus, again by applying the componendo and dividendo. X plus x, we will have here 2x plus x minus x will get cancelled. 4 plus 4 is 8. Next is a y plus y, 2y plus 5 minus 5 get cancelled, plus y minus y get cancelled. 5 plus 5, that is a 10. Okay. Next simplification, that is a x upon y. Okay. There is a x, you will have a x upon 4 is equals to y upon 5. And it implies that x upon y is equals to 4 upon 5. And hence the ratio is 4 as to 5, and this is answer. Now next, example number 17. If a, b, c are in continued proportion, then prove that in bracket a plus b plus c into a minus b plus c is equals to a square plus b square plus c square. Okay. Now as a, b, c are in continued proportion, then you will have a upon b is equals to b upon c. It implies that b square is equals to ac. Okay, now consider the LHS. If we simplify here, that is here you will have here, first you can write here in bracket a plus c plus b in first bracket. What about the second bracket? You can arrange it like this: a plus c minus b. A plus c, in that is considered as a single term, and plus b minus b as a second. Therefore, what is the formula? That is a plus b in second bracket a minus b, and that's equals to a square minus b square. Similarly here, a plus c bracket square minus b square is equals to, okay, then what is the a plus c bracket square? A square plus 2ac plus c square minus b square. Next, substitute the value of b square, that is ac. Okay, Therefore, 2ac is nothing but 2b square. AC is the b square. A square plus 2b square plus c square minus b square. And next simplification. 2b square minus b square, you will have a b square. That is a square plus b square plus c square. That is equals to RHS, and hence it is approved. Okay. Now next problem. If a, b, c are in continued proportion, then prove that a square plus ab plus b square upon a b square plus bc plus c square is equals to a upon c. Now again, as a, b, c are in continued proportion, then you will have a upon b is equals to b upon c. Therefore, by the cross multiplication, you will have here b square is equals to ac. Now substituting the value of b square in LHS, then you would have here, what is LHS? A square plus ab plus b square upon b square plus bc plus c square. Now value of AC is a b square, or value of b square is AC. Substitute here b square as AC, b square as AC. From the numerator and denominator, take a as a common. Okay. Then in bracket you will get here a plus b plus c. Denominator in bracket a plus b plus c. Cancel a plus b plus c. From the numerator and denominator, then you will get here a upon c, and that is equals to RHS. And hence it is approved. Now next, if ABC are in continued proportion, then prove that PA square plus QAB plus RB square upon PB square plus QBC plus RC square is equals to A upon C. As they are ABC are in continued proportion, then you will have a B square is equals to AC. Substitute the value of this B square as a AC. Okay. Then you will have here b square as AC. Okay. That is in bracket you will have. If you substitute here b square AC, okay. From the numerator and the denominator, take a as a common. Then after PA plus in bracket PA plus QB plus RC upon PA plus QB plus RC, these two get cancelled. Then you will have here A upon C, and that's equals to again RHS, and hence it is approved. Next, example number 20. If ABC are in continued proportion, then prove that AB plus BC plus AC upon A plus B plus C whole cube is equals to ABC. Okay. Now see this again here. A upon B is equals to B upon C implies that B square is equals to AC. Now consider LHS. Okay. AB plus BC plus AC upon A plus B plus C. Now again substitute the value of AC as B square. From the numerator, take B as a common. Then in bracket you will get here in bracket A plus C plus B upon A plus B plus C. Okay. These two terms get cancelled. Then you will get here B whole cube, and that is a B cube. Now B cube can be written as B into B square. But what is a B square? B square is nothing but AC, and that is nothing but A into B into C, and that's equals to RHS, and hence it is approved. Now next problem. If ABC are in continued proportion, again then prove that A square plus B square plus C square upon A plus B plus C is equals to A minus B plus C. Very interesting problem. Again, ABC are in continued proportion. A upon B is equals to B upon C is equals to B square is equals to AC. By the cross multiplication. Now consider LHS. A square plus B square plus C square upon A plus B plus C. Substitute the value of B square as AC. Okay. Then make here some adjustment here. By adding AC and subtracting AC in the numerator, then you will have here A square plus AC, A square plus AC plus AC plus C square. Then you will have here A square plus 2AC plus C square and minus AC. Okay. By adding and subtracting. Okay. Here you will have here plus AC and minus AC. If we add AC AC plus AC is a 2AC. Okay. Therefore, you will have a square plus 2AC plus C square. And this minus AC is here. To the denominator, A plus B plus C. Now, to the numerator, what you will have here? A plus C whole square minus B square upon A plus B plus C. Now next, as A square minus B square by using that formula, in first bracket A plus C plus B, in second bracket A plus C minus B. Now here to the numerator, A plus C plus B, that is to the denominator, A plus B plus C. These two terms are equal, same, therefore we can cancel it. And then you will have here A plus C minus B can be written as A minus B plus C, and that is nothing but RHS, and hence we have proved it. Okay. Now next, example number 22. If x, y and z are in continued proportion, then prove that x square minus y square plus z square upon x raised to minus 2 minus y raised to minus 2 plus z raised to minus 2 is equals to y raised to 4. Now as these are in continued proportion, therefore you will have x upon y is equals to y upon z. By the cross multiplication, you will have y square is equals to xz. Now substitute the values. First, y square is equals to xz here to the numerator. What about the denominator? Make this index as a positive. That is 1 upon x square minus 1 upon y square plus 1 upon z square. Okay. But what is the y square here? Y square is equals to xz. Okay. Now next simplification. What is the LCM here? LCM here is a x square z square. And if we simplify, therefore LCM is a x square z square. Therefore multiplied here numerator denominator by z square, and here xz, and here is a x square. The base will be same as a x square and z square. Therefore to the numerator, as it is x square minus xz plus z square, and to the denominator z square minus xz plus x square upon x square into z square. And now if we observe this, that is, this term is a upon, again a upon c, that is a is nothing but a upon 1, that is a upon 1 into, this is the c upon a get cancelled, you will get here c. Okay, similarly here x square minus xz plus z square, these two terms get cancelled, that is the 1 upon x square z square. The reciprocal of this is nothing but x square z square. But what is the x square z square? That is the xz is nothing but y square. Therefore the x square z square is nothing but the square of y square. Therefore y square is to 2. Therefore you will have a y raised to 4. Now next problem. If x, y, z are in continued proportion, prove that in bracket x plus y bracket square upon y plus z bracket square is equals to x upon z. Okay. Now we have given x, y, z are in continued proportion, and hence therefore we have x upon y is equals to y upon z, and hence it implies that y square is equals to x z. Okay. Now consider LHS. Okay. This LHS is equals to x plus y whole square upon y plus z square. Okay. Now expand this, then you will get here x square plus 2xy plus y square, and this whole divided by y square plus 2yz plus z square. Now next, substitute value of y square. What is y square? Y square is xz. Therefore you will have here x square plus, that is here, x square plus 2xy, and the y square is xz. Okay, and to the denominator. What is the y square? Y square is xz plus 2yz plus z square. From numerator, take x as common. Then in bracket, you will get here x plus z, and from denominator, take z as common. Then in bracket, you will get here x plus 2y plus z. And from the numerator and denominator, these two terms get cancelled. And you are getting x upon z, and that is equals to RHS. And hence, LHS is equals to RHS. And hence, we have proved it. What is that? X plus y bracket square upon y plus z bracket square is equals to x upon z. Very easy example. Now next example, that is example number 24. If x is equals to 6pq upon p plus q, find the value of x plus 3p upon x minus 3p plus x plus 3q upon x minus 3q. It's a very easy example. Now divide on both sides by 3p. That is x upon 3p is equals to 6pq upon 3p in bracket this p plus q. Okay, and here that is a pp get cancelled, 6 upon 3, then you will get here 2 pq. Okay, by dividing both sides by 3. Okay, x upon 3p is equals to 2p upon p plus q. Now next, apply the componendo and dividendo. Then x plus 3p upon x minus 3p is equals to 2q plus p plus q, 2q minus in bracket p plus q. If you open the bracket, then what you will get here? 2q plus q, then 3q plus p. For the denominator, minus p minus q. Okay. Therefore, 2q minus q, you will get here q minus p. And this is first one. Okay. Now in this case, we have divided on both sides by 3p. Now we will divide on both sides by 3q. See this here. Dividing on both sides by 3q. Okay. X upon 3q is equals to 6pq upon 3q in bracket p plus q. Again 6 upon 3. Then you will get here 2. QQ get cancelled. Overall, you will get here 2p and in bracket p plus q. That is x upon 3q is equals to 2p upon p plus q. Okay. Now applying componendo and dividendo system, then you will have here 6 plus 3q upon 6 minus 3q is equals to 2p plus p plus q upon 2p minus in bracket p plus q means what? Minus p minus q. Okay, and overall if we simplify this 2p plus p, then you will get here 3p plus q. 2p minus p, you will get here p minus q, and this is second one. By adding 1 and 2, then you will have here that is the x plus 3p upon x minus 3p plus x plus 3q upon x minus 3q is equals to, okay, that is addition of these two again, the right hand side, 3q plus p upon q minus p plus, and this term that is a 3p plus q upon p minus q. Now from this term, denominator, take negative sign as common, then you will have here. Okay. If you take the negative sign common, this term will be as it is. That is 3q plus p upon q minus p, because here the denominator is a q minus p, and here is a p minus q. To make denominator equal, we take from the denominator, take minus n as a common, and hence it will become q minus p. Now by subtracting this, that is a 3q plus p minus in bracket 3p plus q upon q minus p. Now open the bracket. Then you will have here 3q minus q. Then you will have q. Next p minus 3p. Then you will have minus 2p. Again take 2 as a common. Then in bracket you will have q minus p upon 2 in bracket q minus p upon q minus p. Q minus p, q minus p get cancelled and overall, and that's equals to 2. And hence addition of this is equals to. Now next problem. Using properties of proportion, solve for x. X square plus x minus 3 upon x minus 3 is equals to 4x square plus 3x minus 2 upon 3x minus 2. Okay. Now if we observe here, that is here is a term x minus 3 and x minus 3. 3x minus 2 and here is a 3x minus 2. Then applying the dividendo will be useful. Okay. Therefore, x square, by applying the dividendo, x square plus x minus 3 minus in bracket x minus 3 upon x minus 3. 4x square plus 3x minus 2 minus in bracket 3x minus 2 upon 3x minus 2. If you open the bracket, then what will happen? That is plus x and minus x will get cancelled. There is a minus 3 and plus 3 will also get cancelled. Therefore, to the numerator, you will have your x square and denominator is a x minus 3. Similarly here, that is if you open the bracket, plus 3x minus 3x get cancelled, minus 2 plus 2 get cancelled. Therefore, the numerator you will have here 4x square upon 3x minus 2. Okay. Now next by cross multiplication, that is x square in bracket 3x minus 2. Then that is the x square. There is a x square into this 3x. Then you will have 3x square. Next x square into minus 2, minus 2x square. 4x square into x, you will have a 4x cube. 4x square into minus 3, that is a minus 12x square. Now shift these two terms to the right hand side. Therefore, 4x cube minus 3x cube. Okay. Then you will have your x cube. Next, minus 12x square. If we shift this to the right hand side, it will become plus. Minus 12x square plus 2x square. Then you will have here minus 10x square. Okay. Now from here, take x square as a common. Okay. Then to imply that x square in bracket x minus 10, that's equals to 0. It implies that x square is equals to 0 or x minus 10 is equals to 0. X square is equals to 0 means what? X is equals to 0 or x is equals to 10. Okay. These are the values of x. Now next example, example number 26. Find two numbers such that the mean proportion between them is 24 and third proportion them is 192. A very interesting example. Let the two numbers be a and b. Okay. Their mean proportion is 24. Therefore, a as to 24 is equals to 24 as to b. Means what? A upon 24 is equals to 24 upon b. Then by the cross multiplication. Means what? You will have here a upon 24 is equals to 24 upon b. Then by the cross multiplication, a into b is equals to 24 square. It implies that a is equals to 24 square upon b, and this is the first equation. Their third proportion is 192. Means what? A as to b is equals to b as to 192. Again here you can have it like this. That is a upon b is equals to b upon 192. Again by cross multiplication you will get here b square is equals to 192 into a, and this is second one. Substituting the value of a is equals to 24 square upon b in this equation number 2. Therefore, you will get here b square is equals to 192 into 24 square upon b. If you simplify this, then you will get here b cube. Okay, b into b square, that is a b cube is equals to 192 into 24 square. Okay, next the factors of 192 is a 8 into 24 into 24 square. 8 means what? 2 raised to 3, and this is a 24 raised to 3, and hence b cube is equals to 2 raised to 3 into 24 raised to 3. Take cube root on both sides, then you will have b is equals to 2 into 24, and that's equals to 48. Okay, b is equals to 48. Next, find the value of a. A is equals to 24 square upon b. Now substitute here. What is here? Value of b, which is the 48, and then after simplification, okay, yeah, that is a 24 ones are and 24 are 48. The two ones are, the two ones are 2 are 4. Therefore, the value of a is a 12. Okay, and hence finally that two numbers are 12 and 48. Okay. This is the answer. Now next, 6 is mean proportion between two numbers x and y. 48 is a third proportion to x and y. Find the numbers. Same type of problems, but here we have taken x and y instead of a and b. 6 is mean proportion. Okay, and therefore this can be written as x upon 6 is equals to 6 upon y. It implies that x into y is equals to 6 into 6, and that is equals to 36. And hence here first is x into y is equals to 36. This is the first expression. What about the second? 48 is the third proportion to x and y. Means what? X upon y is equals to y upon 48. And it implies that by the cross multiplication, x into 48 is equals to y into y. Means what? Y square. Now here we substitute the values like this. That is what implies here x is equals to, this is the x is equals to y square upon 48. X is equals to y square upon 48. Okay, and what about the from the first equation, x is equals to 36 upon y. Now these two values are equal, therefore their right hand sides are also equal. Then you will have here y square upon 48 is equals to 36 upon y by the cross multiplication. It implies that y cube is equals to 48 into 36. It implies that this y cube is equals to 48 can be written as 8 into 6 into 36. 36 means what? 6 square, and overall you will have here that is a y cube is equals to 8 means what? 2 raised to 3. Okay, now here 6 into 6 square means what? You will have here 6 raised to 3. Take cube root on both sides, then you will have here y is equals to 2 into 6. Okay, and that's equals to 12. The value of y is equals to 12. And what about the value of x? As x into y. Okay, x into y is equals to 36. Okay, therefore, what is the value of y? Put here 12 is equals to 36. And hence here, okay, 36 upon 12, then that is x is equals to 3. And hence the value of x is 3 and y is equals to 12. And this is the answer. Okay. Now next example number 28. If A, B, C, D are proportion, then prove that 11A plus 15B upon 11C plus 15D is equals to in root of 3A square x minus 5B square y upon 3C square x minus 5D square y. Okay. As A, B, C, D are in proportion, therefore you will have here A upon B is equals to C upon D is equals to K, and hence the value of A is equals to BK and the value of C is DK. Okay. Now next, substitute these values in LHS and the RHS. LHS is equals to 11A plus 15D upon 11C plus 15D. Value of A is BK plus 15B. Value of C is a DK plus 15D. Okay. From the numerator, take B as a common. From the denominator, take D as a common. In bracket 11k plus 15, 11k plus 15 cancel. You will get here B upon D. Now what about the RHS? RHS is equals to in root of 3a square x minus 5b square y upon 3c square x minus 5d square y. Okay. Now what is the value of A? A is a dk. Therefore A square is a b square k square. Okay. Minus 5b square y as it is. Next value of C is a dk and hence C square is a d square k square. Okay, 3d square k square into x minus 5d square y. We take b square as a common from the numerator and d square as common. Then the terms, that is a 3k square x minus 5y upon 3k square x minus 5y get cancelled. You will get here in root of b square upon d square. If you take its a square root, then you will get here b upon d. And hence LHS is b upon d. RHS is b upon d. Hence LHS is equals to RHS and hence we have proved it. Okay. Now next problem. Next example number 29. If x is equals to in root of a plus 2b plus in root of a minus 2b upon in root of a plus 2b minus in root of a minus 2. Using properties of proportion, show that bx square minus ax plus b is equals to 0. Now first we have given that x is equals to, we'll write here x upon 1 is equals to in root of a plus 2b plus in root of a minus 2b upon in root of a plus 2b minus in root of a minus 2b. Applying the componendo and dividend. Then you will have x plus 1 upon x minus 1 is equals to in bracket in root of a plus 2b plus in root of a minus 2b plus in root of a plus 2b minus in root of a minus 2b upon in root of a plus 2b plus in root of a minus 2b minus in bracket in root of a plus 2b minus in root of a minus 2b. Again here from the numerator in root of a minus 2b plus and minus get cancelled, and to the denominator in root of a plus 2b in root of a plus 2b get cancelled. Then you will have here x plus 1 upon x minus 1 is equals to 2 in root of a plus 2b upon 2 in root of a minus 2b. Okay. Next, here 2 will get cancelled, squaring on both sides here. Then you will have here x plus 1 bracket square upon x minus 1 bracket square. X square plus 2x plus 1. X square minus 2x plus 1. Here root sign will get cancelled. You will have a plus 2b upon a minus 2b. Okay. Next, again applying here the componendo and dividend. That x square plus 2x plus 1 plus x square minus 2x plus 1 upon x square plus 2x plus 1 minus in bracket x square minus 2x plus 1, and that's equals to, okay, here I will write here one more term, that is a plus 2b plus a minus 2b, this whole divided by a plus b minus a and plus 2b. Okay, here plus 2b minus 2b get cancelled. A plus a, you will have 2a. Next, plus a minus a get cancelled. 2b plus 2b, that's a 2 in bracket 2. Okay, again here this 2 will get cancelled. You will get here x square plus 1 upon 2x. Here 2 will get cancelled, a upon 2b. Okay, and next you can take here the cross multiplication. Okay, that is here 2b in bracket x square plus 1, and that's equals to a into 2x. And next, after simplification, here what is here from the both the sides, again 2 will get cancelled. That is a bx square plus b, and here is a ax. If we shift this ax to the left hand side, it will become minus bx square minus ax plus b is equals to 0, and hence it is a proved. Okay. Now next problem. If x is equals to in root of a plus 1 plus in root of a minus 1 upon in root of a plus 1 minus in root of a minus 1, using properties of proportion, then show that x square minus ax plus 1 is equals to 0. Again, the same type of the problem is. For the solution, here we will write here x upon 1 is equals to in root of a plus 1 plus in root of a minus 1, and this whole divided by in root of a plus 1 minus in root of a minus 1. If we apply here componendo and dividendo, then you will have here x plus 1 upon to the denominator x minus 1. Here in root of a plus 1 plus in root of a minus 1 plus in root of a plus 1 minus in root of a minus 1, and this whole divided by in root of a plus 1 plus in root of a minus 1. And if we change the sign of the denominator, that is in root of a plus 1 next plus in root of a minus 1. Now here these two terms will get cancelled, and here again these two terms will get cancelled. Then you will have here x plus 1 upon x minus 1, and that's equals to, okay, 2 in root of a plus 1 upon 2 in root of a minus 1, and again this implies that, okay, here 2 will get cancelled. Okay, now squaring on both sides, then you will have here x plus 1, okay, whole square upon to the denominator x minus 1 whole square is equals to square and root sign will get cancelled. Then you will have a plus 1 upon a minus 1. And next simplification, that is this implies that, now open the bracket. What is here? X plus 1 bracket square means what? X square plus 2x plus 1 upon x square minus 2x plus 1 is equals to a plus 1 upon a minus 1. Again applying the componendo and dividendo, then you will have here, what is that? X square plus 2x plus 1 plus x square minus 2x plus 1, and this whole divided by, okay, x square plus 2x plus 1 minus, we will change the sign of the denominator, minus x square plus 2x minus 1, and that's equals to, what about here, right hand side, a plus 1 plus a minus 1, and this whole divided by a plus 1 minus a, and here is a plus 1. Now here plus 1 and minus 1 get cancelled, plus a minus a get cancelled, and here you will have, that is a 2a, 1 plus 1 is 2. Okay, next plus 2x minus 2x get cancelled, plus x square minus x square will get cancelled, and overall you will have here, what is here, x square plus x square, that is a 2x square. Here is a 2x square, 1 plus 1 is 2, and to the denominator 2x plus 2x, you will have 4x plus 1 and minus 1 get cancelled, and here 2a upon 2. Then you will have here a upon 1, and this implies that if we take 2 as a common, then in bracket you will have x square plus 1, this divided by 4x, and that is equals to a upon 1. Now here we will simplify, 2 ones are 1, 2 twos are 4. It implies that here x square plus 1 upon, here is a 2x, and that's equals to a upon 1. And after cross multiplication, that is, then you will have here, that is a x square plus 1 is equals to 2ax, and finally after simplification you will have here, that is a x square minus 2ax plus 1 is equals to 0. This we want to prove, that is x square minus 2x plus 1, and hence it is approved. Now next, for the next problem, if x is equals to in root of 2a plus 1 plus in root of 2a minus 1 upon in root of 2a plus 1 minus in root of 2a minus 1, prove that x square minus 4ax plus 1 is equals to 0. This example asked in, that is a 2020 examination. Now again, solution, this is here x upon 1, and that's equals to in root of 2a plus 1 plus in root of 2a minus 1 is whole divided by in root of 2a plus 1 minus in root of 2a minus 1. Then applying the componendo and dividendo, you will have here x plus 1 upon x minus 1 is equals to in root of 2a plus 1 plus in root of 2a minus 1 plus in root of 2a plus 1 minus in root of 2a minus 1, and this whole divided by in root of 2a plus 1 plus in root of 2a minus 1 minus in root of 2a plus 1 plus in root of 2a minus 1. Now here these two terms get cancelled, and these two terms will get cancelled, and overall you will have here in root of 2a plus 1 upon 2 in root of 2a minus 1. Here 2 will get cancelled, okay, and then it implies that x plus 1 upon x minus 1 is equals to in root of 2a plus 1 upon in root of 2a minus 1. Next, squaring on both sides, then you will have here x plus 1, okay, x plus 1 bracket square upon x minus 1 bracket square is equals to 2a plus 1 upon 2a minus 1, and it implies that x square plus 2x plus 1 upon x square minus 2x plus 1 is equals to 2a plus 1 upon 2a minus 1. Again applying the component and dividendo, then you will have x square plus 2x plus 1 plus x square minus 2x plus 1, and this whole divided by x square plus 2x plus 1 minus, sign will change here, x square plus 2x, and here is a minus 1, and that's equals to 2a plus 1 plus 2a minus 1, and to the denominator 2a plus 1 minus 2a, and here is a plus 1. Now we have plus 1 and minus 1 get cancelled, plus 2a minus 2a cancel, and from here plus 2x minus 2x get cancelled, plus x square minus x square get cancelled, plus 1 minus 1 is also get cancelled, and here you will have that x square plus x square, then there is a 2x square, and 1 plus 1 will have here 2, and to the denominator 2x plus 2x you will have here 4x, and that's equals to, next here is again 2a plus 2a, then you will have here 4a, okay, and to the denominator, okay, plus 2a minus 2a get cancelled, and that is equals to 2. Again this implies if we take 2 as a common, then in bracket you will have 2 as common, x square plus 1, and to the denominator 4x, and that is equals to 4a upon 2, means what, you will have a 2a upon 1, and this implies that x square plus 1 upon 2x, and that is equals to 2a upon 1. And lastly, after the cross multiplication, you will have here, that is a x square plus 1 into 1 is a x square plus 1, and what about the right hand side, 2a into 2x, and it implies that x square minus 4ax plus 1 is equals to 0, and in this way we have proved it. Okay, now next problem, problem number 32. If a, b, c, d are in continued proportion, then prove that 3a minus 7d upon 7a plus 3d is equals to 3a cube minus 7b cube upon 7a cube plus 3b cube. Okay, and here we observe the coefficient of a is 3 and coefficient of d is 7. Okay, now as a, b, c, d are in continued proportion, then you will have here a upon b is equals to b upon c is equals to c upon d. Okay, let the value of each ratio is equals to k. Then first c upon d is equals to k, therefore c is equals to dk. Next b is equals to ck, but what is the value of c? C is a dk. Substitute here the value of c, dk into k. And therefore you will have here b is equals to dk into k, means what? Dk square. This is the value of b. Next, a upon b is equals to k, therefore a is equals to bk. Substitute the value of b. What is a dk square? It's a dk square into k. Therefore the value of a is a dk cube. Okay, these are the values of a, b and c. Okay. Now next, consider the LHS. 3a minus 70 upon 7a plus 3d. If we substitute the value of a, that is a dk cube, that is a 3 dk cube minus 70 upon value of a, 7 dk cube plus 3d. If we take d as a common, then in bracket you will have 3k cube minus 7 upon d. Again take the d as a common, 7k cube plus 3. Okay, dd will get cancelled. Okay, and finally here you will have, we'll write here 3k cube minus 7 upon 7k cube plus 3. Similarly, for the RHS, that is a 3a cube minus 7b cube upon 7a cube plus 3b cube. Substitute the value of a. A is a dk cube and again it's a cube. Then you will have here d cube k raised to 9 minus b. What is the value of b here? The value of b is a dk square and it's a cube, that is a d cube and k raised to 6. Similarly to the denominator. Okay. Now from the numerator take d cube and k raised to 6 as common, and from the denominator k cube and k raised to 6 as a common. Then in bracket you will get here 3k cube minus 7 upon 7k cube plus 3. Okay. D raised to 3 into k raised to 6 upon d raised to 3 into k raised to 6 get cancelled, and therefore here we'll get here after cancellation here, that is a 3k cube minus 7 upon 7k cube plus 3, and this is the second one, this is the first one. Therefore from 1 and 2 LHS is equals to RHS and hence it is proved. Okay. Now next, ABCD are in continuous proportion. Prove that. In bracket a square plus b square plus c square into b square plus c square plus d square is equals to in bracket ab plus bc plus cd whole square. Okay. Now as ABCD are in continuous proportion, a upon b is equals to b upon c is equals to c upon d, and that's equals to k. Therefore finally c upon d is equals to k. It implies that c is equals to dk. B upon c is equals to k means what? B is equals to ck. Substitute the value of c, that is a dk. Therefore the value of b is a dk square. And lastly, a upon b is equals to k. A is equals to bk. Substitute the value of b, that is a dk square. And after simplification, you will have here a is equals to dk cube. Okay. Now first see here. Now here consider LHS is equals to in bracket a square plus b square plus c square, bracket complete. Second bracket b square plus c square plus d square. Now substitute the value of a. That is, what is the final value of a? A is a dk cube and it's a square. Therefore, d square k raised to 6. B square. The final value of b is a dk square. Its a square is a d square k raised to 4. And lastly, c square. That is a d square and k square. In next bracket, b square plus c square plus d square. The value of b is a dk square. Its a square is a d square raised to 4. Next is a c. Value of c is a dk, d square k square, and lastly d square. From the first bracket, you can take as a dk square as a common. Okay, and from the, if you take d square k square common. Then in bracket you will have k raised to 4 plus k square plus 1. From the second bracket take d square as a common. Then in bracket k raised to 4 plus k square plus 1. Okay. And next, here is a d square into d square, d raised to 4. Next, into k square in bracket k raised to 4 plus k square plus 1 whole square, bracket square. Okay. Now, next, RHS. AB plus BC plus CD. Now again, substitute the value of A. dk cube, B is a dk square, B is a dk square, C is a dk, C is a dk, and D is as D. Okay. And after multiplication, you will have D into D square, K cube into K square, K raised to 5. Next, dk square into dk, that is a d square k raised to 3, d square k square, d square into k. Okay, bracket complete. Now, from this bracket, you can take as a d square k as a common. Then in bracket, you will have here k raised to 4 plus k square plus 1 and this bracket square. And finally, here is a d raised to 4 k square in bracket k raised to 4 plus k square plus 1 whole square. Okay. And this is the second one. Therefore, from 1 and 2, this is the first one and this is the second one. From 1 and 2, LHS is equals to RHS and hence it is approved. Okay. Now, next example. Example number 34. What same number should be subtracted from 23, 30, 57 and 78 so that the remainders are in proportion? This example asked in 2004 examination. Okay. Let that number be x. Therefore, 23 minus x upon 30 minus x is equals to 57 minus x upon 78 minus x. Okay. After cross multiplication, it implies that 20 in bracket 23 minus x into 73 minus x is equals to 57 minus x into 30 minus x. And next, after simplification, you will get here 23 into 78, 1794. Next is a minus 78x. Next is a minus 23x plus x square. Again, simplification, 57 into 30, 1710, minus 30x, minus 57x, and lastly plus x square. From both sides, x square will get cancelled, and normal simplification is here. 1794 minus 78 minus 23. Then you will get here 101x. To the right hand side, 1710 minus, okay, 87x. Okay, next simplification is 1794 minus 1710, and that's equals to 101x minus 87x. Okay, next simplification is a 84 is equals to 14x, and hence x is equals to 84 upon 14, and then x is equals to 6, and this is the number, and hence 6 should be subtracted from each of the numbers. Okay, so that all will be in a proportion. Now next, question number 35. If B is a mean proportion of A and C, then prove that AB plus BC is the mean proportion between A square plus B square and B square plus C square. Okay. Now this is the mean of these two. Therefore, the square of this is equal to product of these two numbers. Okay. As these are in continued proportion, or B is a mean proportion of A and C, means what? A upon B is equals to B upon C. It implies that B square is equals to AC. Mean proportion of in bracket A square plus B square and B square plus C square, that is a in root of in bracket A square plus B square into B square plus C square. Okay. Now what is the b square? B square is AC, and again b square is AC. Okay, now substituting, that is a b square is equals to AC. From the first bracket, take A as a common. From second bracket, take C as a common. Then what you will have here, that is a in root of AC. But what about here? That is AC in bracket AC plus AC A plus C into A plus C means what? A plus C bracket square. And this root sign, bracket square and root sign get cancelled. Therefore, you will have here A plus C in bracket A plus C into in root of AC, in root of AC. Okay. And next, what is AC? AC is nothing but B square. That is root of B square is nothing but B. Okay. And next simplification, that is a B into A. Then you will have AB. B into C, you will have BC. And hence, that is a AB plus BC is a mean proportion of A square plus B square and B square plus C square. And hence, we have proved it. Now next problem. If B is a mean proportion between A and C, then show that A raised to 4 plus A square into B square plus B raised to 4 upon B raised to 4 plus B square C square plus C raised to 4 is equals to A square upon C square. Now first, as B is a mean proportion between A and C, then you will have here A upon B is equals to B upon C. It implies that B square is equals to AC. Now consider here LHS. This is the value of B square. Also we required here B raised to 4 also. And therefore B raised to 4 is equals to A square and C square. Now first here we will consider the LHS. Now LHS is equals to, what is here? A raised to 4 plus A square B square plus B raised to 4, and this whole divided by B raised to 4 plus B square C square plus C raised to 4. Now the value of that is a raised to 4 is A raised to 4. Next is A square into B square means what? AC. Therefore is AC. B raised to 4 is A square C square, and this divided by B raised to 4 again, which is the A square C square. Again B square is AC into C square plus C raised to 4, and that's equals to, here is A raised to 4 plus A square into A, that is A cube C. Next is A square C square. Okay, and for the denominator you will have here A square C square plus A C cube plus C raised to 4. Okay, from the numerator take A square as a common, then in bracket you will have A square plus AC plus, here is a C square, and in the denominator what is common here? C square is common. Then in bracket you will have here A square plus AC plus C square. Now these two terms will get cancelled. Then you will have here A square upon C square, and that is equals to RHS, and hence here LHS is equals to RHS. Okay, and hence it is a truth. Okay, this is a very easy example. Okay, and in this way we have completed full chapter ratio and proportion. If you like this video, then share it with your friends. Okay, Now we will see in the next chapter. Till then, goodbye.